Good evening, everyone. Thank you all for joining our virtual session tonight. This is the student information session. Just a few house rules before we begin, please. If you could kindly just switch off your mics, just stay muted. We will be taking questions and answers at the end of the presentation, so you can just please jot those down in the Q&A chat box or just in the chat box. And then, yeah. So those are just some of the housekeeping rules. You will be getting the copy of these slides as well as the video recording just a few days post the presentation. So just please be on the lookout for that email. You can also access the recording on YouTube once it's uploaded. That should be in about a week or two. Again, welcome. This is our student information session. Your future in engineering starts here. On today's agenda, we've got the purpose of the session is to provide prospective students and their sponsors with a clear understanding of our college, that is the Engineering College of Science and Technology, and our program offerings. You'll also get to discover the institution where you learn about our mission, our value, our accreditation status, as well as our student-focused learning environment. You will also be able to explore the engineering programs, as previously stated, where you gain insight into the program structure, the curriculum, the practical experience, as well as the career pathways presented by our lecturers. You'll also get to learn about the support informed decisions, where you get to understand admission requirements, application processes, student support, as well as funding opportunities to plan your future accordingly. All right, so for tonight's session, our presenters will be Ms. Lisa Rootman. This is our head of college. We've got Busisiwe Mateo, that's myself, the quality assurance officer. Samkelo Nene, our lecturer, as well as Mr. Freaky Marks, also our lecturer. So you'll get a chance to engage with everyone here. So just please listen to all the various presentations and read your questions. I am now going to hand you over to Ms. Lisa Rootman, our head of college. Thank you.
Thank you, Busi, for the introduction. Good afternoon, everybody. Thank you so much for joining us for the Engineering College of Science and Technology's information session. We hope that you will gain the information today that you're looking for, and please ask questions in the end if there's anything that we didn't cover that you'd like to know more about. So first of all, our mission is to deliver cutting-edge applied engineering education that enables our students to achieve measurable and lasting productivity gains in their workplaces, and to do this in South Africa and beyond. So who are we? We are a newly accredited higher education institution in South Africa. We are accredited by the CHE and provisionally registered by the Department of Higher Education and Training. We are endorsed by ECSA. We registered on the NQF. We'll touch on the SAQA number shortly, and we really are committed to develop students that can add value, or graduates that can add value to the engineering industry. So the details of our qualification. So for our Bachelor of Engineering Technology in Electrical Engineering, this program is offered on NQF level 4. It has 425 credits. It's offered over 3 years, where traditionally it's offered over 4 years. And if you want to go and look at our SAQA qualification, you can welcome to have a look at ID 123645. So the focus of the qualification, and both Samkelo and Frikkie will be touching on this a little bit more, is electrical systems, automation, energy efficiency and sustainable technologies, and it includes industry-based learning and practical exposure. So there's also a pathway to ECSA's professional registration for professional engineering technologists. So just to explain that, I did mention earlier that our qualification is endorsed by ECSA, the Engineering Council of South Africa, which means once our students graduate, they can register with ECSA, and it takes approximately 3 years. You register at first as a candidate, and then once you obtain the necessary qualifications and meet the requirements, you can register as a professional technologist. Also, our program is delivered in a blended model, and we're going to look at the model a little bit more now. So our blended model is first year is fully full-time, so it's on campus, face-to-face. Second year is blended, so it's about 50% online, 50% face-to-face. Third year is mostly online. And the reason we're doing this is because we want our students to start integrating into the workplace. Our curriculum is aligned to industry because we want our students to be able to immediately be integrated, as I said, into industry, and it's also developed by industry professionals. There's practical and hands-on components in our curriculum. We've got strong student support systems that we'll touch on in a little bit. We're very proud of the team that we have together to support our students, whether it be the support staff or the academic staff. And then we have pathways to employment and further studies. So ECST students have the opportunity, once they have completed their degree with ECST in South Africa, to articulate to a master's degree with EIT in Australia or ECT in the UK. So to touch on our admission requirements, so you need a National Senior Certificate, NQF Level 4 with a Bachelor pass of 50% and above for English, 60% and above for maths, 50% and above for science, for physical science, and you need to have basic computer literacy. We also have RPL, and students who are 23 and above can apply with the Matriculation Board, or otherwise known as USAF, or students age 45 and above can apply for age exemption as well. So how do you apply with us? So you can log on to our website and you can apply to become a student with ECST. So at the moment, you'll see that it says a non-refundable fee of 500 Rand. To apply, we are waiving the fee at the moment only for our July 2026 intake. You have to upload your relevant qualifications, your matric results, your ID, etc. And if you are a student from another country, so foreign qualification, you will also have to go through the Matriculation Board. Then I also just want to touch on here to say we currently running an early bird discount. So if you enroll soon, you get 10% discount off the fees. So we're going to look at the fees shortly. So the enrollment process, if your application is successful, you will be provided with an acceptance letter, an enrollment contract, and a payment plan, and thereafter registration takes place. What is the ideal student for ECST? We are looking for motivated and curious students that are committed to learning. As you've heard now with our admission requirements, there has to be a strong foundation in maths and physical science. And if there's anybody that needs support with digital literacy or foundational skills, we can also assist with that. Okay, I just touched on the fees as well. So we've got different payment options. So there's the full payment. There is a 5% discount if you pay in full. Like I said, at the moment, we've got the 10% early bird discount for our July intake. There are other opportunities. We are affiliated with, or we are, one of our partners is Student Hero. Our students can apply for loans with Student Hero. And we can also provide financial support when it comes to a specific payment plan where you pay pay over, for example, 10 months for the fees. You can see our fees for year 1, 2, and 3. Please note that the fees reduce from year 1 to year 2 and from year 2 to year 3. Student support and development, we also touched on this a little bit earlier. So student support for us is one of the most important things of our institution. So we want to ensure that we enable our students to succeed with this program. So we have a learning support officer who is in place specifically for a program and guides our students step by step throughout the duration of their studies. The rest of the team is also there to assist, and also then specifically the lecturers. So we've got academic tutoring and mentoring. We have career and employability workshops. We look at student wellness and counseling. And for us, it's so important to create an environment that is inclusive and supportive. Okay, so here's some pictures of our facilities. So here you can get a feel for our campus. So you will see classrooms, workshops, equipment. There's recreational facilities. So we're quite lucky in terms of where our campus is based. We're surrounded by a lot of amenities. We have the Hull train around the corner. We've got buses, other public transport. We've got safe parking for students with their own vehicles. We've got the Mall of Africa close to us, but a lot of smaller centers. There's quite a bit of student accommodation. We also have a recommended partner in terms of student accommodation, but should you prefer private accommodation, there's those options as well. Also medical facilities, etc. So really surrounded by a lot of amenities. And yeah, we want to invite you, as I show you our facilities, to please come to campus, have a look at our campus, get a feel for our campus, meet all of us so that we can show you around. You're welcome to attend our next open day, or you can book a campus tour on our website. Thank you, Busi.
Thank you, Lisa. All right, over to Samkelo.
Good day to everyone. I hope you're all good. I'll quickly go over the curriculum. So in essence, this program focuses on uh, the delivery of applied engineering principles, design and practical skills in electrical systems, so from power to electronics and communications. So this is the first year sort of outline of the modules that we offer, starting from engineering mathematics, and electrical circuit theory and analysis, where we sort of learn the basics when it comes to tools that we use later. And then also we touch on engineering dynamics and mechanics, which will help when we later learn about the rotating machines or rotating electrical machines. And then we also do engineering design and drawing, which is also uh, sort of a critical aspect of engineering. And then we do industrial experience research, where we will then sort of learn the soft skills part of engineering. We'll learn about research, learn about uh, managing a project, and also in terms of presenting your work. And then the second semester, we continue with engineering mathematics. I'm sorry, we're still on first year. Second semester, we continue, we advance with with mathematics, and then we sort of have an introduction to programming, which will also help us later, and then the fundamentals of electronics, which builds on the fundamental tools that we started learning in electrical circuit theory, and then physics and chemistry for engineers, and then part B of the industrial research. So in essence, the first year is sort of like a foundational phase, foundational sciences and engineering. That's where we sort of establish mathematical and scientific base, which will be required for the advanced module. Moving on to the next slide. And then year two, which is blended, a mix of online and campus study. So these are the other modules that we'll be doing for the second year. Again, so these are more If you look at, okay, the first is mechanics of machines. So it's sort of like a continuation from the engineering dynamics and mechanics. So we're still learning about the mechanics of machines. As we know, a part of electrical engineering, which is heavy current or power, uh, uses a lot of machinery or heavy machinery. So we sort of learn the physics part of the machinery that we'll be dealing with. And then engineering mathematics tree, so it's more of like advanced mathematics. And then obviously then we move on to more of like specialized electrical field, such as transformers and switchgear, rotating electrical machines. And then we will sort of have a module on project planning, management, and costing. Again, this also touches again on soft skills, which is also important for engineers. And then going to the second semester, we then learn or have a module in power generation, transmission, or distribution. So it's more of like your heavy current, and then also we'll touch on electrical safety, earthing, and lightning protection. So as you see now, we're getting more and more into specialized electrical field. So basically now at this point, we're using all the tools and also the foundation that we established during the first year. And then also we'll touch on power electronics and variable speed drives, power quality and energy efficiency. And then the second part on process planning. And moving on to the second slide, or the next slide rather. And the final year, um, again, we're still now focused on specialized electric field. Also, we also introduced the final capstone projects, but let me just quickly go over the first semester. So we, the first module being the power system protection. So this will build up on the module on the power generation, transmission, and distribution. So now this module will sort of address issues regarding protecting that system, and then also electrical utilization engineering, and then power generation. So this power generation, obviously, it will be sort of more specialized, where now we will look at the alternatives, as whereas in the second year we looked at the conventional generation. So here we will sort of look at like renewables, your wind, your solar, and then the following module is also more sort of specialized in terms of electrical control circuits and PLC programming. That's where then we will then use the basics that we learned during our second semester first year on engineering programming. And then the last module in the first semester, third year, we will touch on technology, sustainability, and society. Again, this speaks to again to the or addresses the soft skills part of engineering. So where we will sort of like learn about awareness as to how then our work affects the community, the world, the environment, and so forth. And then the first module, second semester, is data communication for power system monitoring. So that's also sort of specialized. So this is the communication part of the program. And then we will have our final year project where we will sort of apply everything that we have learned in the previous semesters, in the previous module, where we will have a project. Then the students will then either choose, or the lecturer will then provide topics for students to choose from if they don't have a specific topic they want to work on. And then obviously then they will have freedom to sort of go do research and apply all the principles that they've been learning, so from designing to implementation. And then the last module is the second part of technology, sustainability, and society. To the next slide, we'll see. And then this is our workshops. So they will they'll run throughout the 3 years of study. So basically, this is where all the theoretical concepts are converted into practical engineering skills. So we have 4 workshops. The first is based on engineering sciences. If you think of the first year where we focused on the foundation of sciences and mathematics, so the first workshop will will sort of be based on that, where then we'll be converting those theories, those concepts, those foundational sort of like skills into practical engineering skills. And then the second workshop will be on power and control. And then the third will be on transmission and protection. And then the last will be industrial design. And also it is important to note that one has to then do and pass these workshops in order to pass the degree, and also to meet exit level outcomes for investigation, experimentation, and also the use of engineering tools. And then that's all. And Mr. Marks will then touch on the specifics regarding the workshops. Thank you.
Thank you. Fricky, over to you.
Okay, so the talked about the workshops. I just want to get to the next slide here. Oh, sorry. Okay, so as mentioned, our first workshop is about measurement and science. So we start right at the beginning, where we then cover the science type of subjects that you've done in your first year. So we do experiments in the lab, and some of these, so as you can see, we start with the basic ohmic measurement. So we look at the components in the basic level. So it starts with the discrete components. We do the proper measurements from either for the passive as well as the active components that you can see in the picture here. So in that sense, we start right in the beginning of the measurement cycle, and there's the measurement on the other side when we move over to the active components. Where part of that also is to look at Planck constant setup. So now we've got different light emitting diodes. They operate in different bands in the light spectrum. So and some of them are in the infrared spectrum. So you basically have to use your cell phone to see that they are on. But it's the basic experiments to not just look at how the component work, but also understand what the principle of operation of these different components that we deal with in the first experiment. So there you can see the experiment switching on the different LEDs, and then look at the region in which they work. So part of that to use the oscilloscope and your signal generator to do some measurements on sound as well. So we're using a small amplifier within the signals coming from your signal generator. And this is basically audio test as well. So you can see in practice, if we talk about the spectrum, the audio spectrum runs from 20 hertz to 20 kilohertz. It's some of the students in our last workshop, they were comparing up to what frequency they basically could hear the sounds. So that's part of the first workshop. Then the second one is about power and control. So now we've done the basic science experiments, then we go over to power and control workshop. So we start with the electronics and wiring. So we looked at individual components in the previous experiments, but now we are putting them together. So we start with a Vero board, and then assemble some of these components, do some measurements, and then eventually we end up with a printed circuit board, where we've got a whole circuit that we put together, and if you solder it correctly, then your experiment will work. But what we also do is communication. We look at all the mediums that we use today for communication. Because communication has changed a lot, so communication has become much faster. and that's why we use high quality LAN cables and in the optical fiber cables. So it's a part to assemble these cables. Practical, we're going to use it to basically do an experiment in industrial communications. But also part of this is to look at the basic of our generators and our motors, both on the AC and the DC sides. So we've got the basic components that you need for a motor that we put together, and the people attending the workshop must then look at how it works, do some measurements again, waveforms on the oscilloscope to see what sort of waveform comes out of the generator, and if you can get the motor to work correctly. Then we move to the control circuits. So the H-bridge is a method that we use for controlling motors, and our control is pulse width modulation. Part of this is also then, so the H-bridge and the PWM, that's the basic circuit that we need inside our variable frequency drive. But then we go onto the variable frequency drive our squirrel cage induction motor, look at what happens as we increase the frequency, what happens with the current, and the torque relationship. And then we go over to the Arduino kits to do some of the basic measurements that we use in industry. So doing a temperature measurement, humidity, but now on the Arduino kits. The Arduino kits we also then use for the H-bridge so that we can control the DC motor. And then we go on to advanced control. So having a robot that can follow a line. And this robot, we must again, as Arduino circuit, so you must program it so that the robot are able to follow this line. Then we move over to PLCs, timers, and traffic light simulation. Now the PLC, the programmable logical controller, is something that we use in industry to control a wide variety of different processes. After that, we go into the next electrical industrial automation engineering workshop. So previously, the PLC that we've done was basic simulation, because a part of that you've got available is your remote labs, where we've got all the different software, so you can write your program, you can download, and you can test your PLC program. And eventually you can download that and watch from a distance to see if your program works correctly. That is what you do in that at that activity. The last activity here, the traffic light simulation, because that traffic light simulation, you can remotely program and then watch if your program is working correctly. But when we get to the workshop number 3, we have a PLC training kit, which you now need to not just program, but also wire correctly to do certain activities. So there's a variety of different activities that we do. So one of them is the couple tanks. So you must control these tanks by writing a PLC program, do the wiring correct, and then see if your tanks, the flow works correctly. Then there's also, again, AC motion control with your variable frequency drive and PLC. So now in our previous workshop, we just used the VFD with the motor, but now we also add the PLC so that we can also do the control part that is associated with motors in industry. But also, as mentioned, we do power transmission and distribution. So now we've got free phase, which we then can couple to free phase motors and generators. So we do both, and we end up with a motor generator set. So any generator at the prime mover. So now we have the motor as the prime mover, as you can see in this picture, to drive the generator so that we can generate electricity. So a small power system that we then manipulate. As I mentioned, many of these activities, because in a normal lab, and that will be part of your first year, because then you will be on campus where you have access to the labs. But with a remote lab, there's a remote lab infrastructure in between. So as I said, with the PLC, you can write the program, you can step through the program to see if it operates correctly. So there is a simulation that you can use. And then afterwards, you can download it into a PLC, which sits remotely from you. And you can use the camera to see if that traffic lights work according to the way you programmed your PLC. So that's something that you will then start using from your second year, which is a blend between on-site and then remote learning. And then also you can do that for your final year. So there's a variety. So there's the PLC program for the traffic lights as an example, but there's a variety of wide variety of programs that's available for the different subjects. And there's the traffic lights, what you see from the camera. So there, and the PLC. So once you've loaded in your program, you can watch if your traffic lights work correctly. Okay, and that's my part of the presentation. Then back to you.
Thank you very much, Ricky. We've got here our career pathways as well as the industry relevance. So we've already taken you through the industry relevance. Our head of college has already done that with regards to our ECSA endorsement and just how our program is developed by our industry experts. With regards to career pathways, our graduates will have a diverse employment opportunity, which is really one of the pinnacle points of studying. You want great employment opportunities. So you will have these opportunities to pursue careers as registered professional engineering technologist. Again, this we've already touched it. They can also work across manufacturing, industrial, chemical, military, just a whole lot of range. There's different sectors that you guys can go into when you've pursued our qualification. I've also just listed them there, so you can just please peruse these on your free time. Let's see. All right, so that is it for our information session tonight. I am not seeing anything yet in the question and answer chat box. So if there's anything that you want to ask, just please jot it down in there and then we'll address it.
Lucy, perhaps while we wait for some questions, we can clarify in terms of the workshops that we touched on. When do these workshops take place? So, for example, the workshops take place, there's a specific time allocated in the timetable for workshops. It can be when this just before students come back from their break, it can be during induction week or the week before. So we schedule specific periods for students to attend these workshops.
Thank you, Lisa. I don't know if anyone else wants to add anything while we just give it a few more minutes for questions. You can also just feel free to raise your hand if you don't want to type. If you maybe want to ask the question, you are most welcome.
So Busi will also be sharing our information, but on our website is also our WhatsApp number, our email address. So please, if you don't want to ask a question now, you're more than welcome to send a WhatsApp today or tomorrow. Sonia will get back to you tomorrow, or via email, then the relevant person will get back to you. Thanks, Busi, for sharing that.
So another thing that potential students and parent sponsors can do, you can visit our website and there you'll find all of our information. You can find the link to our application form, which if you're interested, you can then apply and our program advisor will contact you. If you want more information, you can also just go to our events tab where you can join in on other events. We've got webinars, we've got other events that are taking place. So you can also just join into those and just get a feel of what the college is offering. So I'm not getting any questions. So I think we can conclude. And thank you again, everyone, for attending. It is the evening, so thank you very much for your time. Thank you to the presenters also for affording us their time and just presenting. Thank you very much. Good evening, everyone.
Thank you, Busi. Thank you,
Thank
everybody.
you.
Bye-bye.
Bye.